Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 2 to the power of 6 is equals to 2 minus n to the power of 6. We will solve this problem for the real values of n. So the very first thing we are going to do is, here first I can move this n to the power of 6 in the left hand side, and you will get its output in the form of n to the power of 6 plus n plus 2 to the power of 6, and whole is equals to 2. And after this step I can rewrite this equation as, here you have n to the power of 6 and I can write it as n plus 1 minus 1 and its whole power 6, plus similarly here we write n plus 2 as n plus 1 plus 1 and its whole power 6, and whole is equals to 2. And after this step I can just take some substitution here, because here you see that n plus 1 be the common term on both of the terms, so that here I can just take y is equals to n plus 1. So when you can put here y is equals to n plus 1, then this equation will becomes in the form of y minus 1 and its whole power 6, plus here you have y plus 1 to the whole power 6 is equals to 2. And after this step again I can write this in the simplified form, so that again I can make some little bit substitution, so that here I can just put a is equals to y minus 1. I can put here y minus 1 is equals to a, and y plus 1 is equals to b. So that if you have a is equals to y minus 1, so this implies that if I can take the square on this term on both of the sides, then you will get here a squared is equals to y squared plus 2y, y squared minus 2y plus 1. And similarly you can take the square on this term and you get b squared is equals to y squared plus 2y and plus 1. So I can rearrange these two expressions, or you can just add these two expressions and you can just get here, if you can add these two one, so you get a squared plus b squared is equals to, here you have y square plus y square and 1 plus 1 2, so you can write it as 2 times of y square plus 1, and minus 2y and plus 2y are gone. These are cancelled out each other because this is negative and positive terms, so they are cancelled. And if you can multiply these two terms, then you get here a square multiplied by b square, then it is equals to y square plus 1 whole square and minus 4 times of y square. So I can get these relations from a and b. And now when you can put a and b in this equation, then you will get here the output in the form of a to the power of 6 plus b to the power of 6 and whole is equals to 2. I can put these two values in this given equation. So now here you can see that we have a to the power of 6 and b to the power of 6, so that I can write it as a squared and its whole cubed plus b squared and its whole cubed is equals to 2. And now you can apply the nice cubic formula here, so that its cubic formula is a plus b, and here you have the value of a is a square and the value of b is b square, so it will becomes a square plus b square and times of a to the power of 4 plus b to the power of 4 and plus minus a square and b square, and this is whole is equals to 2. And now you can just rearrange these terms, as here you have a square plus b square times, we can write this equation as a square and its whole square plus b square and its whole square. I can add and subtract here 2 times of a square and b square. So I can add 2a square plus b square and subtract 2 times of a square and b square, and this is the minus of a square b square, and this whole is equals to 2. And after this step I can take the little bit simplifications here, so that you will get a squared plus b square times, here you have a square plus b square plus 2 times of a square and b square, so it will be equals to a square plus b square and its whole square. And here you have minus 2 times of a square b square minus a square b square, it is equals to minus 3 times of a square and b square, and this whole is equals to 2. And now we can substitute the values of a square plus b square and a square times of b square, these values. Here we can find the value of a square plus b square is 2 times of y square plus 1, and a square times of b square is equal to y square plus 1 whole square minus 4 times of y square. So that we can put these values in this expression here, and you get the value of a square plus b square is 2 times of y square plus 1. And similarly here you have the square, so that you get 2 times of y square plus 1 and its whole square, minus here you have 3 times of a square and b square, and the value of a square times of b square is y square plus 1 whole square minus 4 times of y square, and whole is equals to 2. And after this step I can just simplify the terms, so that here you obtain 2 times of y square plus 1 into, here I can separate the square and you get 4 times of y square plus 1 whole square, and here you get, I can multiply this 3 on both of the terms, and you get minus 3 times of y square plus 1 whole square, and this is minus times of minus will becomes plus, 3 4s are 12, y square is equals to 2. And now you can see that here we have plus 4 times of y square plus 1 whole square and minus 3 times of y square plus whole square, and here you get 2 times of y square plus 1 into, here you obtain y square plus 1 whole square, because 4 minus 3 is equals to 1, and here you obtain plus 12 y square and whole is equals to 2. And after this step I can just here you have 2 and 2, so that we will divide both sides by 2, so that this 2 and 2 are gone, and you obtain y square plus 1 times of y square plus 1 whole square plus 12 into y square and whole is equals to 1. And now I can again take some little bit substitution, so that here I can take t is equals to y square plus 1. So if you have t is equals to y square plus 1, then this implies that y square is equals to t minus 1, so that you can substitute these two values in this expression, so that here you get y square plus 1 is equals to t, and this is y square plus 1 will becomes t square plus 12 times of y square, and y square is equals to t minus 1, and this whole is equals to 1. So that now you multiply this t on both of the terms, and you get t cubed plus, you can multiply this t 12 by t, and you get 12 times of t square minus 12 times of t, and we move this one in the left hand side, and you get minus 1 is equals to 0. And now we can rearrange the terms so that I can combine this t cube by -1, and we can take common plus 12t from both of the terms, and you get t minus 1 is equals to 0. And you can open this cubic formula and you get t minus 1 times of t squared plus t plus 1, and here you have plus 12t into t minus 1, and this whole is equals to 0. And now you can take common t minus 1 from both of the terms, and you get t squared plus t plus 1 plus 12t is equals to 0. And finally you can get here the two cases. The first case is you take t minus 1 is equal to 0, and the other case is you take t square plus 13t plus 1 is equals to 0. So in this case you get the value of t is equals to 1, and in the second case you can apply the quadratic formula and you obtain the final value of the question is minus 13 plus minus 165 square root over 2, so that here you see that it will becomes the negative, or it is less than 0. So if this term is less than 0, so it means that it gives the no real root, because in this question we need the real roots, so that we will rejected this case, and I can just proceed here this case only. And in this case you have t is equals to 1, and now we can back substitute the value of t, and the value of t is y square plus 1, so that you can put here the y square plus 1 is equals to 1, so that here you get y squared is equals to 0. And now we can again back substitute the value of y, and here you see that the value of y is equals to n plus 1. So when you can put here n plus 1 and its whole square is equals to 0, so that here you get the two values of n, and here you obtain two cases. The first is n plus 1 is equal to 0, and other case is again n plus 1 is equal to 0. So finally you obtain the two real roots, which is n is equals to minus 1 and minus 1. So these are the two real roots of this question, and you can obtain the four complex roots on this equation. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.